up, everybody? Welcome to Coffee Hour with Paul Abernathy. Guess what day it is? You guessed it. It's hump day. We made it halfway through the week. We're on the down slide. We're at the crest, getting ready to move down. You've made half the money you're going to make this week. You're going to make the rest in the rest of the week. But welcome to Coffee Hour. Again, my name's Paul Abernathy. You've never been to the show. Thanks for joining me here in the morning at 8 a.m. Eastern Time every morning, Monday through Friday. We have Coffee Hour, and we also play the replay every day at about 5 p.m. Eastern Time. We're located on the East Coast. We relocated from Texas, so if you're new to the channel and you didn't know that, now you do. We were in Texas. Now we're in Virginia, so we're on East Coast time, although I still work on Central Time, so go figure, right? Thanks for joining me. Still want to do again a John. I wanted to give a shout out to John, who sent me the email yesterday. John, who passed his master's exam, gave us a lot of praise, but really it's all about you and the dedication that you put into it, John. So congratulations on getting your master's license in Delaware, I believe. And so I love living vicariously through the students and people that are part of our family, our Fast Tracks family. So, do me a favor. Let me know in the comments who you are, where you're from. If you're a Fast Track student, where you're at in your studying in your program. Let us know what achievements you might have recently achieved. All those type of great things. We love to share it with everybody. And again, thanks for coming to the show, because I know you can do all kinds of things 8 a.m. Eastern Time. And some of you out there on the West Coast, it is real early, right? You choose to spend your morning with us here at Coffee Hour. So, man, I do appreciate it. We're not going to try to jam any sales down your throat. We will tell you that the show is sponsored by TradeHog. So if you want to check out TradeHog and get a really neat AI tool to help you in the field, there you go. It's a monthly subscription program. You can cancel at any time. But we appreciate your subscription. And again, it might save your butt one time and it'd be worth it. I'm just saying. So thanks for joining us. If you're looking for a great electrical training program, we have tons of them over on Fast Tracks System. That's FastTrackSystem.com. Go check them out, from grounding and bonding to post-licensing courses, to residential, commercial, to exam prep questions, whatever you need. And of course, lastly, we have Fast Tracks Tube, which is our video delivery platform. And some of you, I'm sure Rob is, watching us over on Fast Tracks Tube as well. So thank you for making all those platforms an extreme success. We're glad to have you. Couple announcements real quick before we get in and do some thank yous and meet some of you folks. So remember, holler out. We are in the final stages. Jeff has now got all the names and he's putting them together so we can do the drawing. So the first quarter's drawing will take place hopefully by the end of this week, but I'll let you know. It'll be a special show. You won't miss it. It'll definitely be clear in the title. So make sure you subscribe to all of our channels so you'll know. And that's when we're going to do the giveaways. We have the hashtag win turned off, even though you can still do it. It's off right now because we're not starting a new quarter, second quarter. We're not starting that one until next week. And then we'll have new prizes and all that kind of stuff. But if you want to do the hashtag win, because you never know when I may do something wacky, right? So anyway, that's getting compiled. We'll take care of that. Jeff is working on that. I'm working on that. And we'll get the drawing, and it'll be very clear who won and who didn't win. So that's to come. So again, thanks everybody for the last couple months who participated in that and joined us and did the hashtag win and got selected for the drawings and things like that. And of course, all the people that won the free subscription to Fast Tracks Tube. Hopefully you've already enabled that, or you've done it and you reached out to us and we've elevated you. Okay, hopefully. If not, reach out, provide us the information, and we'll get you elevated so you can get the access to that stuff. So anyway, enough said about that. Announcements. Number one, we will be bringing back a segment where you can call into the show. Okay, so that's exciting news, right? That's going to allow you to be able to call in and have a conversation with me, ask a question live on the show. Be nice, because it means that if you're not nice, you'll never ever be on the show again. But we're going to be adding that call-in segment back to the show in the morning, and incorporating that in. And We also are going to be doing some other segments, but we need the bandwidth. So we're still waiting on that bandwidth thing. Again, Firefly is just moving incredibly slow in this area. So hopefully that'll get squared away. We do use Starlink. And so Starlink can have some issues sometimes. And that's why you'll notice if I go to a screen and it's black for a second, it's probably because of the issue with the bandwidth, that type of thing. But we're going to get it all sorted out. But again, we've been able to make it work, right? We are able to overcome, so it's not a big deal. All right. All right. So again, let's live vicariously through folks. Let's do some shout outs here. Frank, good morning. Glad to have you here, Frank. Doing great is in the house. Paul from Houston. Thank you for joining us today. As Frank reminds us, today is indeed hump day. Mike, what day is it, Mike? Mike, what day is it? It's hump day. All right, there we go. Good morning. Glad to have you here, Marlon, all the way down in Tampa, Florida. Let's see. There's the great out in Los Angeles, up early. Frank, you are on it early. Here's Adam, my unofficial Code Nerd spokesman. Good morning. They have you here, Adam. Let's see here. Rob's in the house. Good morning. Watching over on YouTube. Okay, probably the most popular one people watching is YouTube. And remember, we have 2 channels, by the way, and I encourage you to subscribe to both. It helps us out. We have one that's titled Coffee Hour by Paul. Just search for it. And then, of course, we have Master the NEC channel. So we appreciate that. Christopher's in the house. Good morning, Christopher. Thanks for joining us. These are our regulars that join us every morning. Love it. Love it. Bryson, thanks for joining. Good morning. Terrence, my brother from another mother, up here in the D.C., Maryland, and Virginia area. Good morning. Glad to have you here, Terrence. Born to Plumb. We're going to turn this plumber into an electrician before we're done. Born to Plumb from Ohio. Glad to have you here. Let's see here. John's in the house from Orlando. We have the representation from Florida in the house. We are in talks with a gentleman down in Florida about me coming down and teaching a seminar down in Florida. We'll see how that works out. Robert from San Antonio. Robert, I did get your request over on Let's Ask Paul, so we will do something on that. Not going to do it today. Got to get through residential week, but we will make sure that we do cover something on torquing and all that kind of stuff. Rob's 110.14d wants us to talk all about torquing and how we'd approach it and all that. There are some changes in that 110.14. Of course, that was always required at 110.3b from the manufacturer. They always put torque values on their equipment. So it was always required, whether people followed it or not. But when 110.14d came out, it just made it more prominent. And again, people want to know a lot of times when it came out, it required torquing and calibration and calibrated tools. And then we kind of relaxed it a little bit. You still can use calibrated tools, but in 2023, we relaxed it a little bit and we allowed you to use other things. You've got some devices that are set at a specific value and they break off. So when you torque it to a certain value, they snap off. There's other different options. It doesn't necessarily have to be calibrated torquing wrench or screwdriver in these scenarios anymore. There's other options, but we'll talk about that on an episode, or I might have cleared a lot of that up right there, but we will talk about it. So yes, Robert, I did get it. I want people to know that I do read your Let's Ask Pauls. It takes me a while to get to them because I get literally hundreds of these a week. And a lot of times they're from engineers, lawyers, and be careful with those. But again, just so you know, we do get those. What's up, John? Born in Peru. Thank you. In the house. Rob. There you go. One Rob over on the tube. Okay. Let's see here. Marlon says help you pass your masters in at the end of 2024. Okay. There you go. Still waiting on the board. Sometimes these state boards are slow. Let me just put it that way. You got to wait. But as long as you know you passed it, just wait. Just wait in pride because you know it's coming, right? All right, let's see here. 5 a.m. Adam, look at this. Tradesman mug. Okay. That pride. If you sit on a job site, you're like, hmm. You're like, yeah. What are you? What are you? I'm a master. Okay. Anyway, enough of that. Let's see. Erie, good morning. Student in the program. Glad to have you here. Edward, I see that hashtag win in there. Red Dog. Hola. Hola. Buenos dias, amigo. LA. Welcome from LA. Love having you here, Red Dog. Thanks for being with us every morning. Okay. Let's see here. Charles. Charlie's in the house. What's up, Charlie? Hope everything's going good with family. Richard's in the house. Good morning. Glad to have you, Richard. What is it? Plumtrician. Okay. He's a plumtrician. We're going to make him into a full-fledged supertrician if he keeps watching the show. That's for sure. Mike, thanks for joining us. Motor City. There you go. All right. Keep it going, guys. Let me know who you are, where you're from. Love it. Any stories you want to share, any successes that you've achieved you want to share with everybody, I'm more than happy to shout it out and let you know. By the way, we are streaming on Instagram, 2 Facebook channels, which is the Master the NEC channel and my personal channel, which only has about 135 people that I went to school with on, but it doesn't matter. I still stream on it. I don't care. LinkedIn, we're on 2 channels, Electrical Code Academy, as well as my personal one for business, which it'll be Paul Abernathy, so you can't miss that. And it'll have the Trade Hog as my icon, so you'll know it's me. And of course, we are streaming on 2 YouTube channels, Master the NEC, as well as Coffee Hour with Paul. And of course, over on Fast Tracks Tube, you can watch every morning. And then the replays, by the way, the replays do not show up on Fast Tracks Tube, only the live. I wish they'd fix that, but they say it's not coming anytime soon. So I will say, once we get the bandwidth back, we probably will go back to our old system and use Restream and go back to that. It's a little more costly, but that's okay, because there is some bugs with this thing that I don't like with EVMux, although it is very easy to send out replays. I will say that. Anyway, and of course, Instagram, over Master the NEC on Instagram. We're streaming live there as well. And not to forget the folks that are behind the scenes over on TikTok. We are streaming behind the scenes on TikTok. So there you go. Okay. And it says some of the filters are some of the comments are filtered. So they're already cussing me out over on TikTok, but that's okay. I have filters set. So cuss me out all you want. Nobody will ever see it. So if it makes you feel better, you do you, boo. All right? Just saying. Okay, let's get into the lesson today. Let's see. What is it? Currently state licensed plumber, certified plumber inspector, plans examiner, going electrical towards the end of the year. I appreciate all of you. You're most welcome. Hang around with us. Okay, we love having plumbers in the house. Now, every now and then I might throw a joke your way. All right, but don't take it personal. Just teasing. I'm very proud of our trade, so sometimes we tease. Okay, then. All right, guys, let's get into the day's basics that we're going to cover today. All right, and one of the things I'm going to ask you right up front on this basic is look at the images. Okay, here's a little homework for you. Look at the images and tell me what is odd about these 2 images, or mainly one image. And explain something that we talked about the other day. And let's look at it real quick. Ready? Okay. Here's the image on the screen. Focus on the images on the screen. Now, tell me what in this picture of these 2 images, or at least one of the images, what is considered optional? Okay? All right? There he goes. Hot on the left, cold on the right. Shit goes downhill. I am now a plumber. Oh, man. Come on. Dude, that's cold, Charlie. Dude, that's cold, bro. I mean, don't be treating Born to Plumb with that kind of hate. Come on. Come on. All right. Charlie nailed it. Charlie hit it right out the box. He said that redhead anti-short bushing, that's metal clad cable. Hey, y'all were watching? That is optional. for metal clad cable. If you want to use it, use it. If you don't, don't. If it's AC cable, you got to use it. If it's MC cable, you ain't got to. Now, look, don't bring out the haters in here who say, well, I don't care. That's minimum code. I'll always use one. Well, the problem with that is that tells me that you don't know how MC fittings are listed. That's like saying, that's that old saying is, tell me you don't know how something is listed without telling me you don't know something, how something's listed. That's that old saying is, right? So anyway, so if you want to use them, go ahead. Are you required to use them for MC? Absolutely not. And I had one guy adamantly say, well, why in the world does the manufacturer provide them? Well, I work for a manufacturer, and I'll tell you why we provide them for MC cable from many cases. Because we know that inspectors and other people out there may not know that an anti-short bushing is not required for MC. And before you fail a project, we'll give them to you, and maybe you can get by this project by using them. If that AHJ is ignorant enough not to know the difference, go for it. But that's the only reason we provide them with MC cable. And if I had my way, we would give none to you for MC cable, okay? Because they're not required, and they just cost us money to be able to supply you. So I'd rather not supply them personally. All right. Okay, so let's get into this. Conductor identification. So cable assemblies we're talking about today. Generally, a conductor with a continuous white or gray covering shall be used only as a grounded circuit conductor. That's 200.7. Of course, we have the NEC popped up. We can go look at that, but that's the general statement. If we're going to be using a conductor for the grounded circuit conductor, or in most cases for residential, it's going to be a neutral. If that's the case, 200.7 says it's going to be white or gray continuous covering. Okay. All right. Now, equipment grounding conductors can be bare, covered, or insulated. Individually covered or insulated equipment grounding conductors must have a continuous outer finish that is either green or green with a yellow stripe. So that's 250.119. I'll remind you, like it always is in our programs, we give you the code reference. Even in the Fast Tracks program, we give you the code reference because you should stop and go look that up. That's part of the process and what makes it different. Right? You can get a lot of stuff where you just read it, but we want you to go in and out of the code book. We want you to get used to flipping through your NEC. So we're going to, hopefully that's your process of how you learn, is go from your lesson, go into the code book, go into the lesson, back and forth, okay? Hopefully that's what you do. Okay. Now, interesting thing about this, I'll just talk about it. MC cable, for example, this is usually, it's a insulated equipment ground, but it's not required to be insulated. So the standard for example, for metal clad cable is that if it's insulated, it's green or green with the yellow stripe. Is it required to be insulated? No. So a lot of times on feeder size or bigger MC, manufacturers will switch over to a bare equipment ground. So it can be bare, covered, or insulated. Doesn't matter when it comes to the equipment ground. Now, the only time it's going to matter is if you're dealing in a situation like for swimming pool applications where they're going to demand that it's an insulated equipment, or if you're in a healthcare facility, then they're going to demand something like that within the cable. So, and there's other types of requirements in 517.13a and b. But at the end of the day, most people don't know that it's not required for us to put an insulated equipment ground in an MC. It could be uninsulated too. Right? That's totally up to the manufacturer. The UL standards allow us to do either or, but most of the time you're going to find it insulated in the MC, especially in the smaller metal clad cable applications. Okay, and of course y'all know AC cable is not going to have an equipment ground in there at all because you're using the armor, right? Okay. All right, so let's go on here to this one. It says conductors used for ungrounded hot conductors. That's be this black one in here or this black one right here. Okay, where whether single conductor or in multi-conductor cables, and this is a multi-conductor cable. This is also a multi-conductor cable. So where you read that in the code and it makes reference to multi-conductor cables, all right? It's most notably like in 310.15c for when you have more than 3 current conductors, it'll make references to multi-conductor cables. Well, all of these are multi-conductor cables. You could throw tray cable in there as well. That's a multi-conductor cable, right? Just kind of for reference, right? And it also says it must be finished in a way that clearly distinguishes them from grounding grounded and equipment grounded conductors in 310.6c. So that takes us into one of the myths that we have. Now, being a myth, and it's the color coding, being a myth does not mean that in your engineer drawings or in your local jurisdiction's rules that they may have adopted, they may have color schemes that they have initiated for their jurisdiction, or it may be statewide, or it may be in some type of engineering drawing that says, look, you're going to use black, red, blue for 120-240 or 120-208, and you're going to use brown, orange, yellow for a 277-487. That is not in the code. Now, we'll talk about high legs and being orange and that type of thing, but just in general, the only things in the code that are color specific is neutrals or grounded conductors being gray or white or any color other than green with white or gray stripes and those type of things. So other than that, at the end of the day, one of the things that we have to remember is that's the color requirement. Okay, so even even equipment grounds could be green where insulated or green with the yellow stripe, but it could also be bare. That's okay. When it comes to the hot conductors, or the ungrounded conductors, there's really, other than a high leg, which if you're going to use a color for a high leg, let's say a delta high leg, then you have to use orange. If you're going to use a color. But that doesn't prohibit you from using orange in a Y system if you want. Everybody thinks that the orange is reserved only for the high leg. That is not true. But when it is a delta high leg system, then you're going to be using for that 208 leg, you're going to be using what? You're going to be using orange if you're going to use colors. Nothing in the code requires you to use colors for that. You could use a marking system, labeling system, numbering system, whatever. You just need to make sure it's clear on the label so the inspector and everybody knows what the nomenclature is, right? And it's also true in a building where you might have two different systems. So I might have a building where I have 277, 480 coming in, and then I have a transformer that's going to drop it down to 12208. Now I've got two different systems in the building, okay? So if that is the case, then I have to make sure that my color schemes the nomenclature is put at all the locations where there's splicing and panel boards in order to make it clear in the system what the different color schemes are. But as far as the color scheme itself, you do whatever you want, right? Unless the engineers call out colors specific and you follow what they say, or if the local AHJs, not what they want, but what's documented, right? What's documented, then they might tell you that documented that all 12240s and 122.8s are black, red, blue with a white neutral. And then they might say that all 277 480s are brown, orange, yellow with a gray neutral. Okay. But again, that's not in the code. That might be in specs and that might be what your jurisdiction has adopted. But that's all. It's nothing. Now, this all started back when NECA and all that started coming up with the colors for identification. It makes sense so that you can identify, and it's great to be standardized because then it's less confusion. But like I used to tell people, I had a lady contractor who used to use great colors, right? Now, 517 is a healthcare facility. If they want something specific, then that's specific, okay? We're talking in general, okay? So if, for example, I'm required to have an insulated equipment ground in 517.13 A and B, right? Anywhere else, I'm not required. Remember, chapters 1 through 4 apply generally throughout the NEC. 5, 6, and 7 can be modified and supplement anything in chapters 1 through 7. So you could have something up in 500 that is going to modify or supplement something, okay? But we're talking general rule, okay? All right. So at the end of the day, let's see here. Where are we at? Got me off topic. Let's get back to our lesson. Okay. So here we go. So again, this is our normal. So again, as long as y'all know that this anti-short bushing is not required. Okay, hold on for a second. Let me get my screen pseudo-oriented. Okay, it's not really oriented very well, but let's get that type of thing. Okay. All right. Hold on here. There we go. All right. So what I'll do is I'll show you. So what Brandon's pointing out is you may have a unique system that's an isolated circuit or for healthcare, which again is going to modify or supplement the general rule. So you always have to be aware of that type of thing. So to show you that, just to show you, and then again, it's clearly, again, EV Mux is having brain farts. It's what he's talking about down here for isolated circuits. Okay, not the norm, not the general application. Okay, here it's orange with at least one distinctive color stripe other than white for the entire length. Okay, then we're talking about the isolation circuit. And then isolated conductor number 2 is brown with at least one distinct colored stripe. Okay, and all those type of things. And here for three-phase systems, the third conductor shall be identified as yellow with at least one distinctive stripe. This is only applicable to this application. So it's not the general rule. Okay, and so that would be here for conductor identification, and when you're dealing with an isolated power system. And again, that is only applicable to that. That's it. Okay, so very unique, specific, and you might find other applications throughout the code as well where it's going to be specific to that. But that is a very specific application. Okay. I can get back to the lesson. Okay. All right, so let's go next. Okay. So again, like we talk about three-phase conductor identification, generally ungrounded conductors can be any color except white, gray, green, or green with a yellow stripe. So we kind of covered that. We're talking generally now. We're talking generalistics when we're talking this stuff. There's people in their career, Brandon, who will never, ever deal with an isolated power system in healthcare. So we can't really focus on those people because that's not the general. That's the, you know that when you're working with that kind of system. So yeah, that type of thing. But we really got to be careful how we teach people. So now, a widely accepted practice is to identify three-phase ungrounded hot conductors as black, red, blue for 208, 120 full-wire systems, for example, and brown, orange, yellow for 480, 277 systems, that type of thing. That's very common. And again, in general applications, which you're going to run pretty much every day of the week, this is probably the color schemes you're going to use. And manufacturers make cables. And this is another example where they're using an anti-short bushing. It's not required, but they're choosing to use it. And it gives us an opportunity to always point that out. But again, you can pretty much have whatever color scheme that you want, except for the high leg on a Delta for normal general applications, that type of thing. But again, be aware of some specialty applications. Or you could have an engineer who specs out something very specific that they want. And you're like, well, that's not code, but it's the engineering design, so you follow what the engineer wants, that type of thing. All right. Now let's talk a little bit about that white conductor, when it can be used, when I can take that white conductor possibly and use it for something other than a grounded neutral conductor or a grounded conductor, right? Okay. So let's talk about that for a second. And we'll go look at the code and see this, because this, again, offers, let me make sure I don't lose my TikTok, folks. All right, so this is also an example, and I'll get us there so we can see it in the code. So this is example we're going to be talking about here is, let's do it here. So this is the use of installation of white or gray conductor or with 3 continuous white or gray stripes, okay? So use of insulation. All right, so this is what we're talking about right here. All right, now, the following shall only be used for grounded circuit conductor unless otherwise permitted in 200.7b and c. So again, that's originally what we said is white and gray, all that only supposed to be used for what? Grounded conductors, right? Or neutrals, but we got B and C. We got B and C. So one of the ones we'll deal with is that obviously circuits of 50 volts or more. That's going to be your normal circuits, right? And then here's where it says the use of insulation that is white or gray or that has 3 continuous white or gray stripes for other than grounded conductors for circuits 50 volts or more shall be permitted only as in the following. Okay. So first thing right here, it says if it's part of a cable assembly, all right, cable assembly that has the insulation permanently re-identified to indicate its use as an ungrounded conductor by marking tape, painting, or other effective means at the termination and at each location where the conductor is visible and accessible. All right, so that's the first part. So people ask me if I pull white conductors in a raceway and I want to re-identify it, can I do that? Because I have some extra ones in there. Can I? The answer is no. This rule only allows you to use a white or gray conductor for an ungrounded hot conductor in a cable assembly. So that's the first one that people just like don't understand. So the word cable assembly is very clear. So MC cable, AC cable, tray cable, all that. Those type of cable assemblies, you're allowed to re-identify. If you have a white, you can use it as a hot conductor. Okay, that type of thing. So you're allowed to do that. Now, there's caveats to that. And you'll notice here that marking tape, and people say, well, is marking tape permanent? I want to argue yes. If you go, and you don't have to wrap the whole conductor, just at its termination. So just go around it once. I will argue that it is permanent. If you wrap it around, for it to come off, you're going to have to make an effort to pull it off. So once it's back in a box or once it's terminated, it's not like it's just going to go, oh, hey, I'm going to fall off. It's not going to happen, guys. Okay. Now, if you use paint, you got to make sure the paint is not detrimental to the insulation. So I wouldn't use oil-based paint, but a latex-based paint or something like that. I wouldn't have a problem with it as long as, again, it can also qualify as other effective means at the termination. So that could also be, I've seen some products from, I think, Racketeer and other people make products that will re-identify, and that is fine. Again, that's not an issue to use that as well. Again, other effective means is basically left very open to the AHJ. Again, that type of thing. That it's very evident that you're re-identifying that conductor to make it a hot conductor. Then I don't think anybody would have a problem with that. Now, it says at each location where the conductor is visible, okay, and accessible. So every junction box, so you just don't do it at the beginning and the end. If it goes to a junction box and people will see it, then you need to make it evident in that junction box as well. So you're going to have to do your due diligence. But if it's a cable assembly, can definitely re-identify. Now, the other thing that people say, is there a size requirement? Because you remember that 4 and larger requirement, things like that? Not applicable here. Okay, there is no size restriction here in a cable assembly. Now, we worked hard to get this changed a couple cycles ago. So again, not a restriction on that, okay? And then it says identification shall encircle, not envelop, okay? Encircle the insulation and shall be of a color other than white, gray, or green, obviously, because you're redoing it as a ungrounded conductor, but you're using the white conductor with the insulation. When we say encircle, that again reminds you that it only needs to be around the end at the termination. A lot of people think you have to wrap the entire conductor with tape, okay? So I'm sure 3M and all those would love you to just keep using more tape, but you only have to encircle it right at each termination and each visible splice point or any point that's accessible, okay? That's all that's required. So just wrap a tape around it a couple times, red, black, blue, whatever you want, and that's perfectly fine, okay? Now, in that same rule, it says, and you do this all the time, you're running 3 ways, you're running 4 ways, things like that, using cable assemblies, and you want to use the whites as travelers, or you want to use the white as supplying it to the switches, then the code says, you know what? The white or gray conductor can be used to feed the switch or can be traveler in 3-way and 4-way switches installations. The white or gray conductor shall not be used as a return conductor from the switch to the outlet, okay? Talking lighting outlet, okay? So that is in 200.7.1, okay? So with that said, this is kind of what we're talking about right here. All right, so see this right here? It's hard to see, by the way. But just to kind of give you an idea, the power source is down here, right? Hey, good morning, Angel. Glad to have you here. Tino, I see you in the house. Thanks for joining us. So the power comes in down here, and you see that it's using the white. So this is just a 2-wire here, right? And the 2-wire, it sends this up here, right? And people are saying, well, why isn't there a neutral in this box? Because there's an allowance for you to not have that when you're switching a receptacle, by the way. We'll look at all that in a second. But anyway, here it goes up on the white. So you're supplying the switch, and it comes back on the black because that is coming to the outlet. This is the outlet right here, folks. This is a device, okay? All right. So in this case right here, they broke the tab because you got one side that's hot all the time, and then the top is the one that's being switched. So I can tell you this may seem very basic, and that's what we're talking basics today, but I can see plenty of people who get this wrong. They actually come back down on the white to the switched receptacle, and that is wrong. That is not what you're supposed to do. Okay, so inspectors will be looking for that because that's not what it says that you can do in 200.7. Okay, all right. So anyway, that's just kind of a layout there. Good morning, Felix. Thanks for joining us. All right, now let's go a little more. So now we're going to get into the switches. So y'all probably are savvy code folk. Y'all know that 404 is a switches article. So now we're going to talk about that grounded conductor. We're talking about switches. So the grounded circuit conductor for the controlled lighting circuit, okay, shall be provided at the location where the switches control lighting loads that are supplied by a grounded general purpose branded circuit for other than locations stated in 404.2c. So we're going to do that. Now, this example right here, just to kind of give you an example, this may be an allowance in the code where you have a bedroom, for example, right? And you don't want to put a lighting outlet in 210.70. So you're allowed to switch a receptacle in lieu of, remember the old saying, in lieu of means other than, in lieu of switching a lighting outlet, that you can switch a receptacle outlet. And so one of the allowances in 404.2 is going to be that if it's obviously for switching a receptacle, then I don't need to take the neutral up there, that type of thing, okay? Now, you guys know common sense. If you're doing this and you ran a 3-wire, for example, then you would just use the black and red for the switching and you bring the neutral here. If you were going to jump out of here and continue on and like go on and feed another circuit. So y'all know all that, right? I don't need to teach you guys rewiring and wiring 101. But again, depending on your layout, it may be more conducive for you just going to run a 14.3 up here. And then you'll have the neutral in this box in order to be able to branch out of here because you have a hot that's coming up here that you can continue around the room. Okay, it's all about your layout, okay? That type of thing. But y'all know that stuff. All right, now, we'll look at 402, okay? So we're going to talk that big thing that everybody talks about is neutrals. When you got to have neutrals at switch boxes and when you don't, all this kind of good stuff. So we're going to cover that. Now, and we're doing residential week, so keep that in mind. We're residential. A grounded circuit conductor is not required at the switch location where the switch controls a receptacle load. So that's what you just heard me, and that's what it's going to tell you in 404.2c4. Okay, if you got your code books with you, go look. We're going to do it really quickly because I want to set precedents that people follow what I tell them. All right, so we're going to go here, and we're going to go to 404. And we're going to look under switches. So 404.2 right here. And I will drop this down. So 402, this is your switch connections. Again, there's your 3-way and 4-way. Okay, yada, yada, yada. All right, and so we're talking about C, switches for controlled lighting loads. Right, and of course, we're looking at C4 right here. So if the switch controls a receptacle load, again, if you're doing the switching a receptacle and lay a bedroom in lieu of 210.70, you're going to be using a switched receptacle. Then in this case, like we showed in the illustration, you're not going to have a neutral at that switch box. Okay, and there's some other allowances right here as well. And the language is kind of, we'll break it down because this is where this gets confusing for people. But we'll break it down, okay, to make it easier for folks to understand. Okay? We always want to keep it easy peasy here. All right, now, individual white or gray conductor in a conduit or raceway shall not be used. You cannot re-identify it. I told you that because it is not a cable assembly. Okay? Just trying to keep you from making mistakes out in the field, my friends. That's all I'm trying to do with that. So, all right. Okay. So now let's get to that big old confusing 404.2c that people have is when do I got to have a neutral at the switches and this type of thing. So let's read this. Take the time to read it with me so we can break it down piece by piece. It says the grounded circuit conductor for a controlled lighting circuit shall be installed at the location where the switch control lighting loads that are supplied by the grounded general purpose branch circuit serving habitable rooms or occupied spaces as defined in the applicable building code. Okay, all right. Is NM considered a cable assembly? Absolutely it is. Absolutely, non-metallic sheathed cable. It is most certainly a cable assembly. Okay. All right, so now that's your general rule. Okay, right there. There's your general rule. Okay. Now it says now where multiple, so this is the rule right here that people follow at first, right? And they go, okay, I got to have a grounded conductor at every switch location. Okay, that's the first rule they follow. But then it says, look, it says where multiple switch locations control the same lighting load, such as the entire floor area of a room or space, and is visible from the single or combined switch locations. So if I'm in a room and I have a three-way switch, and I'm here and I see it, I'm controlling the same lighting load in the same room, then it says, you know what? I don't have to have the neutral or grounded conductor at both locations. Okay? So that means I could have it at only one location. So that's one of the allowances right there, right? So it says if that's the case, then the grounded conductor shall only be required at one locations. Okay? Okay, so visible from a single or combined locations. Okay. Now, a grounded conductor shall not be required to be installed at lighting switches locations under any of the following conditions. Okay, so again, these are conditions where the grounded conductor shall not be required to be. One, where conductors enter a box enclosure that switch through a raceway, provided that the raceway is large enough for all contained conductors, including a grounded conductor. So that means if you have a raceway installed to your switch location and it's big enough and it has enough raceway fill allowance for you to add that grounded conductor at a later date, then that means you can pull one in later. Then you don't have to have a grounded conductor there if you don't need it. Okay? And it's whether you need it there or not is depending on what you're trying to power. But if you don't need it at that switch for anything that you're trying to do, and you have a raceway that has enough raceway that you could add this conductor later, then that's okay. Then you don't have to have the grounded conductor there if you don't need it. Now remember, what people screw up with that is that they see the conductors in there, they do a raceway fill calculation for that, and they don't figure in adding the conductor later. So they might be right at that fill, 40% fill, let's say, but they didn't account for adding another conductor, that grounded conductor. So you have to account for that. Even though it's not in there, you still got to do the math to make sure that, okay, in order to not bring it there, I have to make sure that the raceway has enough ability to add another conductor later without exceeding the raceway fill requirements, right? At Chapter 9, Table 1. Okay, so that's what you got to think about. Shouldn't be an issue, but again, if you start loading up raceways, could be a problem. So keep that in mind. The next would be number 2. It says, where snap switches with an integral enclosure comply with 300.15e. Okay, and so I will take you to that so you can look at 300.15e. So if people like to see what those are talking about. So we'll go to 300.15. 300.15e, and we'll get down to this right here. So this is integral. So this it says a wiring device with integral enclosure identified for use having brackets that securely fasten the device to the wall. Conventional, and I don't know this one. So here you go. So this is these type of things. They're all one complete system. Okay. So typically we see these in manufactured homes, mobile homes. This is a boxless device. Everything is right here. And again, you're not required to have the neutral, and obviously receptacle you would, but the switches, you would not be required to have it in those, that type of thing, okay? Let's get back to lesson. All right, so that's where snap switches with integral enclosures comply, okay? Because you're typically not going to get into, or where you're going to use these are usually pretty limited. They're not something that you'd have to worry about. All right, next three, where lighting in the area is controlled by automatic means. Okay, so if you're running a circuit to it and it's automation and everything's automated, then probably the automation's already going to have the neutral there if it's necessary for the automated process or whatever's going. So it would not necessarily need, if you didn't need one and it was automated, you don't need to have the grounded conductor there. Okay. Now, obviously, if whatever the load is that's being automated needs a neutral, then you'd have to have one there, right? But again, it's not required there if it's by automatic means and it does not require a grounded conductor for it to function, then it would not be necessary. Okay. Now, 4, where a switch controls a receptacle load, we just saw that. So we want to, again, if we go back to the code and we take us back to where we were, just so we can get back into the context of what's in the list. Let's bring it back here. Why is it going back here? Boom, let me go. There we go. Okay, so where we were at was right here. So these are what it was talking about. These are what we just read to you right here. You know, not required. Okay, the grounded conductor shall only be required at one location. That's what we just talked about. It says a grounded conductor shall not be required. Doesn't mean you can't have one, depending on what the load is or what if you happen to need a grounded conductor there. It's just saying it's not required, okay, to be required to be installed at lighting switch locations under any of the following. And those were the ones that we just read to you, okay? All right, makes sense? Okay. Let me get back to the lesson. All right, let's see here. What does, let's see here. David says, I don't let it get you to 10, 20, and those will more than likely not be sized properly anymore. David, I'm not sure what you're saying. Not what you're saying. I'm assuming you're talking about a different topic where we do current carrying conductors and you have 310.15C1 and you get to over 9 and then it's going to probably drop it down to 50% and now you have a conductor that's not good enough for the ampacity. I don't know how that's germane to our topic, but I'm not sure. But anyway, okay. All right, so the next one that we'd be looking at here, just to kind of show you what we're talking about. Okay, so this is a 3-way setup right here. And then this is a source over here. Now, let's say this lighting load, if it was controlled by 2 locations and it's the same area, and I can see this lighting load from the area, then I wouldn't need a neutral at both locations. But in this case, since the source is here and the lighting outlet's here, obviously I need a neutral here at the lighting. That's a no-brainer, right? So I'm coming in right here and I'm bringing in the source, right? And as long as I'm going, so here's the 3-way travelers. So here's the black and red. Here's the black and red. Okay, this is a 3-wire cable with ground. And grounds carry on through, absolutely. And then the neutral is going to carry on through to get me to the load. All right, there you go. And this is a pretty simple way to do it. This is a 3-way. This is your common terminal, bring the power in. You got your travelers that go over. And then it comes to the common right here. These go to the travelers, go to here. And then you have the 1 screw on the side. That's the common. If I put a 4-way switch in here, then you know that the black and the red go to one side of the 4-way switch, or the in and then the out, or line load, however it's configured on your device, then to go out and continue over to here and then back up to here, okay? All right, say, there we go. Again, okay, so David says he was talking about the neutral. The only thing to be careful with that is that depending on the circuit, The neutral may or may not be a current carrying conductor. If you're running conductors in there and it's a multi-wire branch circuit, then the neutral may not be a current carrying conductor. If it's just standard branch circuits, then the neutral is always going to be a current carrying conductor, and it can sneak up on you pretty quickly if you're doing that. So just be prepared. The biggest thing about that rule is to make sure that you understand that if you're going to be adding a conductor later, and you need to make sure that you have enough raceway fill, but you most certainly have to think about the number of conductors. If it is a current carrying conductor, then you're going to be potentially causing an issue with the ampacity of those conductors. So absolutely, thank you, David. Always think about those loads and how you would do that. So look, in this installation, the supply is fed one of the three ways. Therefore, the grounded circuit conductor is already at the switch location. So blah, it's good. Switching the three-way and four-way is done only to the ungrounded conductors. That's correct. A grounding conductor cannot be used as an ungrounded or grounded conductor. Again, that should go without saying, but you know what? I can tell you, I have been on installations where people, and you can tell me if you can share this with me if you want. We won't tell anybody. I have been on installations where somebody didn't have a neutral at a location, and then all of a sudden they needed it, and they're thinking, I've got an equipment ground there. It goes back to the same location as the neutral would go to. I'm going to use that as my neutral because it'll make the circuit at least work. Don't do it. You're going to be putting current on the equipment ground, return current. Neutral current's going to always have to return current. And you're going to potentially energize metal parts, and you're going to create a hazard. You're also going to create a violation of 250.6, which is objectionable current. And you're also going to be making an improper case to neutral downstream application and all those type of things in 250.24b. So, or A5, depending on which code cycle you're in. So don't do it, okay? Don't try to shortcut just because you go out on a service call and you make something work and think, ooh, I'll just wrap that bear with electrical tape and, all the exposed ends. Don't do it, okay? Don't fight the temptation to be a jackleg, okay? I'm just saying. All right. So in this circuit, it's very typical for a three-way. Okay? Now, incidentally, if I brought the load in here at the luminaire, okay, or the lighting outlet box right here, then I would, obviously in this scenario right here, if I would bring the neutral down, okay, so I'd bring the hot down, then I could actually follow my scheme. And depending on where my neutral, I may have neutrals already in these boxes. I may be coming in here. And if I need to get a neutral down to this location, right, it's very important to think of what I might. So I would have to have enough conductors or enough cable assembly to, one, be able to get my neutral down here, right, as well, if I'm fed up here, as well as I got to carry my hot down, okay? That type of thing. Right? So if I need a neutral at these switch locations. Now, if I have a neutral at this switch location, maybe this is a 2-gang box, right? And this location over here has a neutral there, okay? Then maybe I get away with it. But again, I have to have the neutral for that circuit. So this circuit may be one side of a 2-gang, and I might have another circuit in here for another switch to another load, okay? I don't want to intermingle the neutrals because that's a neutral for that circuit. So again, might be necessary to get that neutral down here. So again, it depends on your choice of cable assembly to get you your neutrals where you need to be. All right, so discuss the importance of having a grounded conductor at each switch location. Obviously, the need for that grounded, and in most cases in residential, is neutral. The need to have that is to complete the circuit path, but you also need it for other things, right? So some cases we may have some devices that are motion sensors and things like that has some type of mechanism on them that picks up, that always has a sensing on it, and you do not want to use the equipment ground for that connection because that will put current on the equipment ground, which is connected to the metal parts. So that was done years ago with a lot of those motion sensors and occupancy sensors, and since now, it pretty much is where we're going to make sure that we have separate. So if you have that application, that's the importance of having that grounded conductor there for a lot of those electronic control devices and things like that to make sure that they're going to work and function properly. And so important. Now, residential, just follow the rules. I haven't seen a whole lot of people installing occupancy sensors and all that stuff. I think it's a neat idea to do more in a house, but very few. My brother puts none of those in the big houses that he does, that type of thing. I like the thought of them in closets. I like the thought of them in areas where, bathrooms, where people forget to leave the lights on all the time. So, but again, that's a design thing if you want to do it. All right. Let's see here. Okay, covering for direct burial cables and conductors. So y'all are all familiar with table 300.5, right? So cover measured commences at the top of the surface of any direct burial wiring method, conductor, cable, conduit, or other raceway, and ends at the closest point of the finished grade, top surface, including concrete. So if we're putting any of these wiring methods, in this case right here, we're just going to call it UF. Let's just call it UF or whatnot. So all locations not specified in the table 300.5a, and we'll go look at the table. If it's not specified, and this is the other thing that people forget. Now I am gonna go to the code just so I can show this to you. Depth of cover. This is, a lot of people get this screwed up. So this is for underground installations, by the way. So this is the table right here. Okay, y'all are very familiar with it. Okay, this is, let me get over here in the middle a little bit. Okay, right here. This is minimum cover. Okay, and again, this is for 0 to 1,000 volt AC. Of course, it does introduce now 1,500 volt DC. Okay, all right, but there you go. That's the table we're familiar with. Now I'll pin the heading here. So let's go back to the left. This is interesting because you'll notice that there's a catch-all here. So in all, these are some specific locations that are listed under here, but they may not cover every application that you're involved in. And if that's the case, then you default to all locations. So if something you're doing doesn't meet any of these locations down here, then you default to right here, okay? And then it just depends on what you're doing, whether it's direct burial cable or conductors like USE-2, rigid metal, intermediate metal. Here is going to be like a PVC. Let me go a little further, get you the rest of them here. This is applications where you're doing a residential branch circuit, 120 volts or less, and it's GFCI protected. Type thing. I have no idea why I got clapping going on my TikTok thing, but anyway. And of course, this also, people forget this and the maximum overcurrent protection is of 20 amps. So this is for 15 and 20 amp applications, residential. Then you've got some depth of cover, but here you see the catch-all is 12 inches, right? If you have this type of circuit, if it's not something that's listed down here in the locations. And of course, here's some other type of stuff for irrigation, in landscape lighting and all this kind of other stuff, all right? So let's get back to the beginning. So again, so you have a catch-all right here, okay? That's a catch-all. And then you have other applications that may apply, okay? Keep that in mind. I think it's so important to distinguish that to people because, again, if I had $1 for every person that reaches out about that cover issue, then I'd be a rich man, okay? Rob likes them in his closet and pantry. Absolutely. There's only one place that I don't like what customers used to have me do them, and I loathe them, is the one that the little switches that go into jams. I can tell you right now, I've had doors that are, some of these fancy doors in these multi-million-dollar houses that we used to do, and they want me to cut it in. They want me to do it. Those are a pain in the butt. And I'm always worried that I'm going to split something or split the wood or damage it. I cannot stand those door jam switches. I just can't. I'd much rather have some type of occupancy sensor in there or something like that or whatever. And I would always try to talk them into that type of thing. So anyway, yeah. But yeah, there's been a big push. My brother does a lot of the door jam switches, and he's always nervous as hell cutting those things out because all it takes is one slight hit. The contractors don't want to cut them in. Electrician ends up stuck cutting them in. And of course, you know what happens, right? Something happens. Now my brother's gotten very good. Anytime they've ever cracked, he's a MacGyver, buddy. He can patch it and make it look good. But me, I just rather not do it. So I hate those door jam type switches. But again, that's all not really what we're talking about. Occupancy sensors, anyway, motion sensors. But all right, anyway, so here you go. So here is our general cover right here. Okay, so it's general. If it's not any of the locations that are listed on the left side of 300.5, then it's 24 inches of cover. Now again, that's measured from the top of the wiring method, not to the bottom of the trench. From the top, that's why they call it cover. It's from the top of the wiring method to the finished grade, whatever it may be, okay? And if it's concrete, then you're measured to the top of the concrete, that type of thing. Right? Now, if it is concrete, you may have one of the other allowances that actually let you have a reduced depth, okay? But asphalt, for example, is not listed, so you would include your asphalt. That would be protection. That would be fine. But 24 inches, right? Now, if it's underneath the street, highways, alleys, driveways, and parking lots, and we would even throw parking garages in there in this scenario, grade level, then you would be 24 inches. Again, many people, to reduce the depth, will then move on to do something else, like put it in a raceway or something like that in order to, like a rigid or intermediate, and they would try to reduce their depth of cover, okay? But then, you have to make sure you use that wiring method to get that depth of cover. Now, here is an example where one of the allowances, if you're installing on a 4-inch slab. If it's a 4-inch slab and there's no vehicular traffic, then a slab must extend at least 6 inches beyond the underground. So it's got to make sure it extends at least 6 inches past it. Well, then you can reduce it down to 18 inches. So if you're going under a slab somewhere, it's 4-inch slab, and it's not subject to vehicle traffic, then you get a reduced depth of 18 inches. Okay? But you notice here that it includes the 4-inch slab, right? So that's 18 inches. So basically, it's 14 inches of cover, and then you have 4 inches of slab, okay? Now, check this out. If the trench below 2 inches of thick concrete or equivalent, okay, so here is reduced to 18 inches right here, and you'll notice that that's 18 overall, but you'll see that that's reduction from the 24 if you have a 2 inches of slab, okay? So this is actually done where people can only get down a certain depth, and they'll actually pour concrete over it and then have cover above it, okay? But again, key factor is that allowance right there. Okay? And then 1 and 2 family dwellings, driveways, and outdoor parking areas used only for dwelling-related purposes, okay? And of course, I don't know if that's a big deal or not, but airport runways, including adjacent areas where trespassing is prohibited, then you have a reduction of 18 inches. And of course, the key thing, remember, again, is to understand how the table works. All right, because the table is going to talk about, okay, so for example, here is that slab that we were talking about right here, that 4-inch slab, okay? Right? And there's all the rules there. You see that that's where, if it's direct burial cables, then it's 18 inches, right? But if you put it in rigid metal conduit or intermediate conduit, check this out. It drops all the way down to 4 inches of cover, right? Which effectively puts it right underneath the 4-inch slab, okay? So understanding how these tables work, critically important, and all those type of things, right? Let's get back to the lesson. And I'm running over like I normally do. All right, now, here's other things that people don't think about, and I get calls all the time because we do sell wire and cable, is that if excavation backfill shall not contain large rocks, paving materials, cinder, large and sharp substances in the corrosion. You should dig your trench. Many people dig trenches. They don't properly do the trench. They don't put sand in or crushed gravel or whatever. Okay, I'm not going to be that guy, okay, that harps on your trench. But you should make sure that you go through it and clear out any large rocks, anything that could potentially damage, anything that the cable or conductors are going to be laying on, because when you put the backfill back in it, it's going to compress it down onto it, and it could damage over time as the earth settles. it's going to damage that conductor. So again, clean out your trench, make sure that you don't push any of that backfill in there with large rocks and things like that, because it will damage raceways, cables, or the conductor, especially if it's like a direct burial. And that's the last thing you want, is to damage it once it's in the ground, okay? All right, so again, you just need to protect it. And if it's going to be anywhere that you believe that it's going to be, for example, if you're turning right corners, right, in right angles, and you're digging your trench and that conductors or cables are tightly around the edge, to make sure there's no rocks along the edge. Otherwise, you put something that's going to protect it so it's not going to be an issue in the future. Okay, that's 300.5F. Okay, so make sure you check that out. Okay, and I can share that with you, but it's basically just common sense in that backfill requirement. Okay, but it also makes it clear that you may have to add gravel. You may have to add some form of granular product like crushed gravel, whatever, in order, if you're in an area that has a lot of rocks and it's real evident that inspector comes out there and looks at that trench and sees just rocks sticking up. You have a really rocky area, and they could say, you know what, it's not going to work, dude. And here, how can this impact you guys? If it's all rocky and you have to throw in some type of gravel, or you have to throw in sand, okay, then what ends up happening is now you've reduced your depth of cover, because now your wiring method goes onto it. So you have to take all of that stuff into consideration, because the cover is from the top of the wiring method, whether it's a cable or raceway or whatnot, to the finished grade, okay? So that's something you have to take into consideration, all right? What is next? How about the protection from damage? So protection must extend, and again, at least 8 feet above the finished grade. So we have direct burial conductors and cables emerge from grade. They come out of the ground, right? So you have to protect them up to 8 feet. A lot of times at poles, you'll see them have that protective sleeve that goes over it, okay? So direct burial conductors and cables that emerge from grade must be protected by enclosures or raceways, and they have those nifty little clamshell covers that go over it, okay? There you go. That's 300.5D. Protection must extend below the grade to a depth matching 300.5A cover requirements up to the minimum depth of 18 inches. Okay, so what we're talking about, that is, again, so what we're talking here, let's point out, let me bring you to the code so you can see that. Of course, it's not working, so I'll do this. So here's what it's talking about in the code: emerging from grade. So there's your direct burial conductors and cables as they emerge from grade, okay? And as specified in columns 1 and 4 of this table, shall be protected by enclosures or raceways. So we just saw that, right? At least 8 feet from above finished grade, and in no case shall the protection be required to exceed 18 inches below the grade. Okay, so you can't just have it come out and then put that protective sleeve and stop it at the earth. Okay, it needs to extend down. Right now, if it's service conductors, then it says the underground service conductors that are not encased in concrete and that are buried 18 inches or more below grade shall have their location identified by a warning ribbon that is placed in a trench at least 12 inches above the underground installation. Okay. Now, I get a lot of questions about this one. Not required for that marking tape for a feeder. Not a bad idea. Like if you're going to a detached structure, it's not a bad idea, but it's not required. That marking is required for service conductors, not for feeders. But it's not a bad idea, that type of thing. I'm just saying. But it's not required. But you can do it if you want. Now, what about the residential? Because we're talking residential, and we're going to end it here. I believe we're going to end it. Let me see where we're at. Yeah, we're going to end it on this one here today. All right, residential branch circuits rated 120 volts or less with ground fault circuit interrupters, GFCIs, not GFI or GFP. It's GFCI, okay? Protection and maximum overcurrent protection of 20 amperes. So 20 amperes or less, the maximum will be 20. So if that's the case, in those specific, under that column, if it's not listed as one of the locations, then it's a 12-inch cover. But if it's a 1 or 2 family dwelling, it's a 12-inch cover. If you want to put it under a slab, then you can have a reduced distance. Okay, here 4 inches, right? Here, if it's in a raceway, if it's direct buried, then it's 6 inches. Okay, and see how the slab includes the 4 inches? Yep. And here, if it's below concrete, 2 inches of concrete, then you get your 6 inches reduction from the 12, right? And if it's under streets, highways, or roads, again, this is going to, it doesn't matter. This is going to kick you back up into the 24 inches. Now, why you would want to do a residential one underneath streets, highways, roads, alleys, driveways, and parking lots, other than your normal driveway for your residential, I don't know. But if you did, you're going to have to dig that sucker down 24 inches. What about the low voltage circuits? Again, we're talking about things like landscape lighting, irrigation, and all that kind of stuff. Same thing, you have a column just for that. Okay, 6 inches. If it's not a location that's specified on the table or different parameters on the table, again, you have the option for the 4-inch slab. Can reduce the cable assembly, like the landscape cables. You can have reduction of 6 inches, right? Or if you have a 4-inch slab that can, and you're putting it in a raceway, then you can reduce it to 4 inches, which is basically just the slab. And if you have a 2-inch concrete, you can reduce it to 6 inches of cover. If it's streets, highways, again, still going to be 24 inches. Why you would do that, I don't know, but I don't know. But if it's a 1 and 2 family, okay, then in your driveway, then it's going to be 18 inches for that landscape lighting like that, because there is, yes, it's reduced voltage, but there is no GFCI on it typically in this maybe. So this is going to make you bump it up to 18 inches, that type of thing for cover for that. Not more than 30 volt installations, okay? All right. Let's see here. Discuss the importance of providing the proper burial depth. Conductors and cables can be cut, disrupting power or communications, and can pose a shock hazard. Okay, we're going to get into different types of cable methods tomorrow. Ooh, some flat. Y'all probably never seen flat. Ooh, look at that. Okay, that's what we're going to kind of go over some different methods tomorrow, right? So depth is extremely important. I know people do this and they don't always, hey, what's up, Van Man? Glad to have you here. You can always watch the replay. Depth of cover is extremely important for the longevity of the product. Yeah, I get it. People always do their own do-it-yourselfer stuff and scratch it in the ground. That thing. Oh, I got an interesting thing. I don't know if y'all know this. Our company is going to be becoming a dealer. I don't know if you knew this. You probably didn't mention it. For mini excavators. We've been reached out to and contacted. So we have a nice big property here. And a lot of electrical contractors we're looking for mini excavators to do their own trenching with the smaller buckets and the bigger buckets. So believe it or not, I'm always investing in companies. So we are opening a dealership here in Virginia for mini excavators, and they're going to be very they're going to be very price conscious. I believe we're going to offer one mini excavator for about $6,000, $6,500 for one, which means that it's not like where you got to go get parts from China. It's distributed here, and it has parts and accessories and all, and it's serviced and it's warranted here in the U.S. That's important. And then we're also offering a second model that is a little bit bigger, and it's the one we like, and that's going to be roughly about $12,000. So if you have an electrical contracting business or you've ever thought of a mini excavator, reach out to us. We're going to be a dealer for them, and we're less than 20 miles from the U.S. warehouse, and so they reached out, and we are going to be becoming a dealer. We have a lot of acreage here that would be adequate for that, and they asked if we'd be interested in being an authorized dealer. So you'll hear more about that if you're interested in that type of thing. And so, yeah. All right. Anyway, I don't know a whole lot about excavating, but I have worked with a little mini excavator before, and they are freaking cool as crap. So when they reached out, I was like, hell yeah. No, not Kabuto, but has a Kabuto engine in it, which a lot of people love. Okay, I'll talk about that later if anybody's interested in mini excavators. There's a lot of them you can get from China that are cheap. The problem is there are horror stories with them. They don't really have a warranty, parts, and the ones that we're going to be working with going to have an array of accessories, and it's still considered, I consider it affordable. Any real quality mini excavator that you can get for under 15 grand, for most electrical contractors and landscapers and building, it's an investment. And you can pull it on a regular cart. They're only about 16 to 1800 pounds, that type of thing. So we'll probably do some videos on that in the future once we get that all set up. We're still working the paperwork out on that. But, you know, we're excited about it because, again, yeah, you know, it's just something neat. We're growing the corporation. We're expanding out into all different types of things. So anyway, might not be interested to y'all, but I think it's pretty cool. All right. That is it today, folks. We're not going to do any drawings today because we're still working on it. You'll see the announcement for that. And Jeff's getting all the names in the drawing and that type of thing. And I've already been busy. Thanks for the likes over there on TikTok. I just noticed people are tapping the hearts. Appreciate you. I just noticed that if you haven't noticed, we've been burning. I was playing around on the laser yesterday on TikTok, live streaming. And we're burning the cards for the giveaway. So we're getting you the voltage drop cards. We're getting you the conductor length cards. We're getting all of the engraved stuff that we need to get engraved ready, so that when we do the drawing, we can fulfill those and get them sent out quick as possible. So don't worry, we're working on it behind the scenes. Next week, start a whole new drawing for some new goodies, things like that. So yeah, it's gonna be great stuff. All right, folks, a lot of great things coming. Make sure you share, let other people know about this. Do me a favor, be my little mini Adam French, okay? Go on social media, shout it out, share it on your social media, tell others about it, tell the electricians at your job site, tell everybody you know about Coffee Hour. If you want us to talk about a topic just like Robert submitted about terminals, we'll be covering that 110.14d in a future episode. I listen to what you guys send me. And again, keep sending the emails about your success. I love it. I love hearing about your success, folks. All right? All right, folks. Till next time, stay safe. God bless. And we will catch you on an upcoming episode of Coffee Hour. Take care. God bless. Happy Hump Day. Remember what I said? Don't always be quick to disappear. Okay? Alex, I saw you in here, my friend. Alex, welcome. Glad you came. You came in late. Okay? So, with that said, we're still adding another name to the drawing. I said don't disappear. Let's spin the wheel. And it's not working. It's not letting me pick people. What? Voltage drop card. That is for you, Alex. I'm putting you down because you hopped in here before we left, and I'm putting you down. So, Alex, I'm going to have Jeff add you. Uh-oh. Also now spinning. So, Alex. Let's see, Outdoor Man. So we're going to be doing that. This is VD card. I don't know why it's working now. I know you're here, Christopher. All of you are still here. All right. All right. So let's do another one real quick. Let's do a giveaway. said I wasn't going to do it. For all you folks that still hung around, it didn't disappoint me. It pays. It says the last drawing is 31st, and we're here. But we're going to add Jeff. Jeff, we're going to add you to the list here. Hey! Lucked out, Charlie. You're in the drawing for the G and B course. All right, folks. Just wanted to surprise you there. So those that stayed, 2 more chances. Till next time, say God bless. We'll see you on tomorrow's coffee hour. We're going to pick up. We're going to end out our basics tomorrow because I have something special for the end of the week. All right. Catch us tomorrow. Share it.